All right, so for today, we're going to start talking about DNA replication, and I understand I'm not here for this, and this is the best thing that we can do as far as what real time is concerned. And notice yesterday, one of the things that we saw happening was with this Robert Griffith, or Fred Griffith, did this study when it comes to that of treating mice with two different types of bacteria. And what happens is one was rough, one was smooth. And in that process, what had transpired then is I gotta make sure, the smooth type of bacteria, yes, the smooth strain had killed the mouse. Now this is on page 327. And then once that was heat treated to kill off that bacteria, then injected that into the mouse and it lived. So the rough type of bacteria, which did not cause any type of disease, was injected into the mouse. That type of bacteria with that specific type of DNA, the mouse lived. But for some reason, when he incorporated the heat-treated S strain, which was lethal to the mouse, again, heat treated it, but then mixed it with some DNA of the rough strain, then that killed the mouse. So something must have been happening there where the DNA of the smooth strain was incorporated into the rough strain and killed the mouse. And what that means is there's a type of perhaps DNA replication that had taken place, and that's what we're going to be talking about here. And when it comes to this process, because we want to be able to illustrate the replication of DNA, is that we've got 4 nucleotides, okay? That's one of your vocab terms when it comes to that of DNA, and that is adenine and thymine, and those two bond together, and cytosine and guanine also bond together. So if we have a fragment here of DNA, there's a specific reason these come in 3 letters. We haven't gotten that far yet in the chapter. That's more so associated with the RNA, and we'll get to that later on this week. So keep in mind, one of the things that we want you to be able to do is show this process of DNA replication. And a good way to keep this straight, I always say, I'm going to put you on the spot. What did this mean? We said you have to know where you're blank to know blank. What? How did you keep this straight if you didn't have that information? You have to know that you are blank to know blank. You have to know where you're at. True. You have to know where you're at to know if you are coming or going, which that's true. So then we know that if adenine bonds to thymine, which it does, we would put a T here. Okay? Same thing. And then just the reverse. We've got T here. That's going to bond to adenine. Okay? And then I just want you to take a couple moments to go ahead and go down and make that replication. Or not the replication. I'll finish out the DNA strand, sorry. All right, so by this prior knowledge, we put an adenine here, thymine. We have to know if we're coming or going, so this is a guanine. So cytosine, guanine, adenine, thymine, cytosine, guanine. Okay, cytosine, adenine, and then adenine. And if you looked at that and said, that is incorrect, you would be correct for saying that. So we intentionally did this wrong because adenine can't bond to another adenine. It has to be thymine. But when that happens, sometimes we call that a mutation. And for the most part, all types of mutation, the body can really does a pretty good job of taking care of itself. So a lot of these mutations are probably harmless, but it does happen. But nonetheless, something that, again, nothing to lose sleep over is what I'm trying to say. But in this process of DNA replication, This is a double helix. There's a few reasons how we know that we're dealing with DNA. One is that it's double-stranded. And I'm just putting some dots in here. Just visualize that all the way down here. These are called hydrogen bonds that actually holds this molecule together. Now, what we're going to do is just picture this marker is in the same plane here, kind of like we're going to chop it like a tree, and we say timber, and down it goes. We are turning this DNA molecule on its side. Again, it's a double helix. It's actually spiral shape like this. I'm not that flexible to where I can illustrate that, but you see this wrapping itself around. That's what's actually happening here. So we turn this over, and then we're going to unwind that and do this. Okay, so hopefully all of that is still on there, and it is. So we're going to go in 3-letter segments. Let's see here. 1, 2, 3, 4. So we should have 12. 3, 6, 9, 12. Okay, we're good there. So now what we're going to do is we've got AAT. And then we've got TAC. Okay. CAC. And then GAT. Okay. So we've taken this double helix, we've unwound it, and we've turned it on its side here. And now we're going to go ahead and put these complementary strands back in. Okay. And I didn't leave enough space in here. Sometimes it's kind of hard to remember to actually open up that alligator a little wider, but I didn't do that. But okay, so we have TTA. ATG. Okay, and then of course we don't necessarily have to look up there. We can just go G, okay, T, G, C, then T, and then A. So what we actually see happening, these hydrogen bonds are still in here, but here at this, what we call replication fork, or where these alligator jaws or jaws are actually opening up, we actually have an enzyme in here, and that's another one of your vocab terms, I would presume. This enzyme is called DNA helicase. And what that is doing is it's breaking those hydrogen bonds. Now, one of the aspects we also know that this is DNA. 1, it's double-stranded. 2, this is taking place inside the nucleus. Okay? That's where all this replication is always going to take place, is inside the nucleus, because the DNA cannot leave the nucleus. Okay? So that message for making proteins has to be able to find a way from the nucleus out to the ribosomes where it's made. So some of them we've actually had vocab terms before, ribosomes and nucleus. We know that that's the command center of the cell. That's one way of looking at it. And this is why it's the command center. It contains the DNA that directs all the cellular activities. And again, I understand there's a glare on there, but we have to deal with that the best we can. Okay? And when we talk about replication, just think of this when it comes to, let's say, serving a volleyball. Okay? You serve it and you get an ace. So what do you want to do? You want to replicate that again. You want to do that same process. You serve it, maybe you get another ace. So you have replicated. So you're doing it again and again and again, and that's what replication means. So we've got this molecule of DNA, which means we are going to replicate that. Okay? So in this case, instead of just having one DNA molecule, we're actually going to have 2. Okay? So you can go by this process. You have to know where you're at to know when you're coming or going. Or the outside here is going to be the same as the inside down here, because remember, these are complementary base pairs. And I'll show you what I mean here. We know that thymine bonds to adenine. So we go T, T, and then A. Okay? According to this, which we learned from prior knowledge. We know that thymine bonds to adenine. Okay? So there's A, then we got T, and then it's kind of ran out of space here, but that's okay. Notice that we've already copied these same three-letter base pairs, these three-letter base pairs. Okay? We know that guanine bonds to cytosine. Okay? And we just know that from up here. And notice we got them two. You can just copy these from the inside to the outside here. Because, again, we are just replicating the process. I'm not even looking to see what these letters are. I'm just copying these down here. Okay? So I didn't say adenine's bond to thymine, and vice versa here. I just looked at what the purple was and put this on the outside here. Now you could say the same thing for the outside bottom. You don't even have to go through that process. You can say, well, we know that adenine bonds to thymine, or you can just read the inside here, providing you have done that correctly to begin with. So we got A, T, and then T again, then A, and then C. Okay? So again, I'm not even talking about what nucleotides are bonding to which ones. I'm just reading these because the outside bottom would have to be the same as the inside top. Okay? So hopefully that helps you out a little bit as far as what this process of DNA replication is. So please make sure that you have that wrote down so that when we discuss that once I get back tomorrow, we can keep chugging forward. Okay? So you also have ample time to work on your vocab. I have not formally assigned that yet, but chances are I would be led to believe that perhaps the 20th or 21st of next week is approximately when you'll probably have your vocabulary evaluation. All right, so that was a very quick presentation on information that you will be responsible for, okay? The only thing that we've left out is how this gets sealed back together, but I don't want to go through so much information that you get totally lost, okay? Anyway, and none of this information pertains to yourself. That's why I tried to label that as general chemistry and organic chemistry. So I will just leave this content up here, and if Ms. Weavers chooses to erase that, that's fine too, because you have this on the Science Channel. All right, so that's all I've got. Once you're done with this, any questions, read that on around page 329 maybe, because we read on page 326 yesterday. Okay, so that's all I have. Any questions, come with them tomorrow or ask in class today, and we'll move forward with that and finish your vocab if you want, because one of the things we said, if you have it done, then it's one less thing to have to worry about. Okay, so we'll catch up to you next time.